Salam and welcome everyone. So today we're going to be working on the question on the screen that says estimate the change in molar entropy of N2 gas when the temperature is lowered from 298 kelvins to 273 kelvins, given that the molar heat capacity of at constant pressure of N2 gas or nitrogen gas is 29.125 joule per mole Kelvin at 298 kelvins. Now we're dealing with a change in molar entropy question, meaning that we're not trying to solve for the molar entropy for anything. We're just trying to solve for a change. So the first thing you have to do when you have a question like this is to write out the parameters. We're told that the temperature is lowered from, so we have the T initial to be 298 kelvins, okay? We have the T final is to be equal to 73 kelvins. So given that the molar heat capacity at constant pressure of nitrogen gas, that is Cp, comma m of N2 gas, is 29.125 joule per mole Kelvin. So we're told to estimate the change. So the first thing you have to note is that you've been given all of the parameters. Now we have to use our understanding of entropy in physical chemistry to write out the formula we're supposed to use. So we know the formula is the entropy at final temperature, or the molar entropy at final temperature is equal to the molar entropy at the initial temperature plus the molar heat capacity at constant pressure of N2. Okay, so I'm like rewriting it for this particular question. Actually, let me just ignore plus N2. I'm just going to give you the general formula and then we can go ahead to make it specific to this question. So ln T final, okay, divided by T initial. So you can see this is just the general equation. We have the T initial, we have the T final, we have the molar heat capacity for this question at constant pressure for this question. So that means we can substitute. But you may be wondering, why don't we have the molar entropy for the initial temperature? Well, the question does not require us to find the molar entropy for the initial temperature because we're asked to find the change in molar entropy. So we can rewrite this formula as the molar entropy at of the final temperature, okay, minus the molar entropy at the initial temperature is equal to Cp, comma m, okay, ln T final, okay, divided by T initial. So that's basically how it's done, your change in molar entropy. So change in S is equal to Cp, comma m. I'm just going to rewrite it now in terms of this question. For N2 gas, okay, ln T final divided by T initial. So the change in S is equal to Cp, comma m of N2 gas. That would be 29.125 joule per mole Kelvin. Okay, times ln T final divided by T initial. So that will be 273 kelvins divided by 298 kelvins. So that's how it's done. So having this, we have change in S, okay, is equal to 29.125 joule per mole Kelvin, okay, times, we see now that we have this information here, 273 Kelvin divided by 298 kelvins. We can cancel out the kelvins and we can do 273 divided by 298. So that will be times ln. 273 divided by 298 is 0.91611. So now we have 29.125 joule per mole Kelvin times ln 0.91611. So change in S is going to be equal negative 2.5519 joule per mole Kelvin. So when we multiply what is up here that I'm putting in a box, and you do 29.125 times ln 0.91611. Remember, the ln of anything less than 1 is going to give you a negative value, hence the reason why we have a negative here. So when you multiply both of them together, you have negative 2.5519 joule per mole Kelvin. Now, since we're dealing with a chemistry question, we cannot just say, oh, this is our final answer, right? We have to make sure that we are putting it in the correct number of sig figs, because that's how you work with chemistry problems. So in our question, we have 3 sig figs for 298 kelvins. Okay, we have 3 sig fig for 273 kelvins, we have 5 sig figs for the molar capacity of nitrogen at constant pressure. So we're going to pick the lowest number of significant figures because that's the rule in math or in chemistry, whatever you want to call it. So we're going to end up having our change in S to be negative 2.55 joule per mole Kelvin. So that is basically the answer to this question. So that's how it's done. If you have any questions, make sure you put it in the comment section. If you have any suggestions or concerns, make sure you also put it in the comment section. I help students who are trying to succeed in all their STEM related courses, whether they're in middle school, high school, or college, to succeed in school. I also help students who are trying to have bigger dreams and bigger goals by mentoring them. And if you have any need for my services, you can email me at yohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.